Climate change and its consequences are among the key challenges that humanity is facing. This is why it is so crucial to develop new measures to reduce and mitigate CO₂ emissions. A promising way to combat climate change is through carbon capture for utilisation technologies. To capture CO₂ from the air or from bio-based industrial emissions and obtain high-value molecules that can be used to produce sustainable materials. The VIVALDI project has been experimenting at laboratory scale with a new biorefinery concept based on carbon capture for utilisation technologies. VIVALDI tested a combination of electrochemical and bioelectrochemical processes using captured CO₂ and nitrogen-rich water, followed by a fermentation process involving genetically modified microorganisms to produce organic acids such as formic, itaconic, succinic, hydroxypropionic, and lactic acids. These acids can be used to produce useful chemicals and materials for several industries. They can be found in innovative, biodegradable and disposable products, such as packaging, compostable bags, textile fibres, or cosmetics, among others. Using these CO₂-based materials instead of petroleum-based plastics reduces emissions across the product's life cycle. This is a vital step towards achieving a low-carbon economy. But how feasible are these solutions on an industrial scale? These technologies are initially tested in a laboratory setting, and after years of development, they may be implemented in full-scale industrial biorefineries. At the Beta Technological Centre, we conducted a prospective life cycle sustainability assessment of the VIVALDI biorefinery, considering environmental, economic, social and circular dimensions. This involves designing theoretical industrial biorefineries that do not yet exist and assessing the scalability and feasibility of these processes. The assessment involved creating scenarios that considered the increasing pressure on companies to reduce their carbon emissions and the requirement to align with the European climate and energy objectives for 2030 and 2050. This prospective analysis enabled us to identify key exploitable results that could be upscaled and eventually introduced to the industry. Tomorrow, VIVALDI CO₂-based products could be a reality at your home.